Good day everyone. In this video, we are going to talk about separation of variables. So, in this lesson, it introduces the method of separation of variables for solving first order ordinary differential equation. So, we will learn to identify and rearrange equations into a form where all terms involving one variable can be separated from all terms involving the other. So, through work examples and practice, the module covers the techniques of integration on both sides of the separated equation to obtain a general solution, emphasizing the constant of integration and the handling of initial conditions. So, as learning outcomes, we will define variable separable. We will perform algebraic manipulation to separate variables to form g of y dy is equals to f of x dx, and we will apply the variable separation as a first step in solving first order differential equation. So let's get started. So in our lesson, let's first define what is separable variables. So a separable equation is a first order differential equation in which the expression for dy dx can be factored as a function of x times a function of y. So in other words, it can be written in the form dy dx is equals to g of x and f of y. So the name separable comes from the fact that the expression on the right side can be separated into a function of x and a function of y. Equivalently, if f of y is not equal to 0, we write dy dx is equals to g of x over h of y, where h of y is equals to 1 over f of y. To solve this equation, we will write it in the differential form. So, h of y dy is equals to g of x dx. Now let's have our first example. Solve the differential equation dy dx is equals to x squared over y squared. So first we write the equation in terms of differential and integrate both sides. So dy dx is equals to x squared over y squared. So in order for us to easily solve and integrate this by their dy and their dx, we can have a multiplication. So it is easier to separate this by multiplying y squared dx to both sides. So now we can have y squared dy is equals to x squared dx. Now that we separate both variables into their respective dy dx, we will now integrate this both sides. So we have integration of y squared dy is equals to integral of x squared dx. So the integral of y squared dy is equals to y cubed over 3 by the rule of integral, same as 2x squared. We have x cubed over 3, and therefore the final answer is 1/3 y cubed is equals to 1/3 x cubed plus c, where c is an arbitrary constant. We could have used c sub 1 on the left side and another constant c sub 2 on the right side. Now for our second example, we have here solve the differential equation dy dx is equals to 6x squared over 2y plus cosine y. So we write the equation in terms of differential and integrate both sides, same as we used earlier. So we have dy dx is equals to 6x squared over 2y plus cosine y. So in order for us to separate, we will think of a good to multiply in this equation so that it is easy for us to integrate the both sides. So we can multiply 2y plus cosine y dx to eliminate the denominator. So now we have 2y plus cosine y dy. So both y is in the dy. And for the other side, we have 6x squared dx. Now that we've separated it in their dy and dx, we can now integrate it. So we have integral of 2y plus cosine y dy is equals to the integral of 6x squared dx. Since we have a constant, we can separate 2. We can put that outside the integral. So we have y dy plus integral of cosine y dy is equals to 6. Since 6 is a constant, we can also separate that outside the integral. So it remains integral of x squared dx. So we integrate it. We have 2 multiplied to the integral of y dy, y squared over 2 plus sine y is equals to 6 multiplied to x cubed over 3. So the final answer is y squared plus sine y is equals to 2x cubed plus c, where c is the constant. Now for our next example and the last, we have solved the equation dy dx is equals to 6y tan squared 2x. And now let's solve it. So we have here, we write the equation in terms of differential and integrate both sides. So we have dy dx is equals to 6y tangent squared 2x. So we can multiply 1 over y over dx to eliminate and to separate both y's and both x. So now that we multiply 1 over y dx to both sides, we have a remaining of dy over y is equals to 6 tangent squared 2x dx. Now that we've separated to all the y and all the x, we can now put an integral sign. We integrate both sides. So the integral of dy over y is equals to ln of y. So in order for us to easily integrate the other side, we will rewrite it as 6 secant squared 2x minus 6 so that we can separate it easily. And now that we've done this, we can also separate the constant because we have here a subtraction sign. So we have the integral of 6 secant squared 2x dx minus 6 dx. So we have now ln of y 6 times 1/2 tangent 2x minus 6x plus c. So ln y is equals to 3 tangent 2x as we simplify it minus 6x plus c. So therefore, the answer is y is equals to c sub 2 e raised to 3 tangent 2x minus 6, where c sub 2 is equals to e raised to c sub 1. That's all. Thank you.